we can have some more example on the load characteristics. Is that the question? Example number 4. The example number 4 says that the load duration curve for the power station is given, like this is the load duration curve for a power station where this is the load and this is the time, 100%. So, if the plant capacity factor is 70%, we have to find the reserve capacity. We have to find the reserve capacity. So in this question, as we can see that this is a load duration curve. So maximum demand is right now 50 and the average demand here is the maximum demand is 90 and the average demand is 50 megawatts. And the plant capacity factor is given as 70%, and we have to find the reserve capacity. So one can understand from here that the plant capacity factor we know is the average demand upon the plant capacity. Plant capacity factor is given, average demand is given, so we can find the plant capacity as is equals to the average demand which is right now 50 what is the average demand right now? Is that 50? Some people do that as a 50, but the average demand, if we see that, is not 50, is 50 plus 90, that is equals to. So first of all, we need to find the average demand, which is equals to the 90 plus 50 divided by 2, which is equals to 70 megawatt. So this is the thing which we need to understand. The average demand is right now 90 plus 50 by 2, and 90 plus 50 by 2 will be the average demand, which will be approximately coming over here, which is 70 megawatts right now. So the plant capacity would now be 70 divided by the plant capacity factor 0.7. So we will be getting plant capacity as 100 megawatt. But we need to find the reserve capacity. So we need know the formula for reserve capacity is like reserve capacity is equals to plant capacity minus the maximum demand. So here the reserve capacity we found is 100 and maximum demand is 90. So the answer is 10 megawatt is the reserve capacity of the total system. This was example number 4. We can have an example number 5 also. We can have example number 5 as the maximum demand on the system is 15,000 kilowatts. the annual load factor is 50%. Plant capacity factor is 40%. So we have to find the reserve capacity again. So in the example number 1 or 2, I suppose, we found the plant capacity factor is equals to average demand upon rated system capacity. So we can replace this average demand right now from maximum demand into load factor. So the maximum demand is already given, the load factor is already given, plant capacity factor is already given, so we can find the rated system capacity now. The plant capacity or the rated system capacity, whatever. Rated system capacity from this formula would be maximum demand, which is equals to 15,000 kilowatt multiplied by my load factor, which is 50%, it means that is 0.5 divided by the plant capacity factor, which is 0.4 or 40%. So the rated system capacity from this is 18,750 kilowatt. So again, we have to find the rated reserve capacity. So our reserve capacity would be equal to my rated system capacity minus the maximum demand. Rated system capacity is 18,750 minus of maximum demand, it is 15,000 kilowatts. So the reserve capacity would be 3,750 kilowatts. So this is another objective type of question which we have done almost in 2 or 3 minutes, suppose. So since I'm explaining this to you, so it is taking 3 minutes almost time. But in the exam, you have to do it very fast, and this is very short example. And this is an objective type of question which have been asked in some public sector examination and engineering services examination also. So this is also important from GATE point of view and from other engineering services examination point of view. So we can go for another small example on the same as example number 6. Example number 6. This is also a question which have been asked in some examination, that the density of the water is given. Is given as 1000 kilograms per meter cube. We have to find the power developed by the hydropower plant. If 100% efficiency is there, efficiency is 100%, we have to find the power developed with the head is given as 1 meter, head is given as 1 meters, and the distance is 1 meter cube. The discharge is 1 meter cube per second. So we have to find the power developed. We have seen this formula. This is a direct formula right now. We have seen this formula in the when we were studying about the hydropower plants, and the direct formula which somebody might be remembering. The power developed by a hydropower plant is equal to 0.75 upon 736. Sorry, 736 divided by 0.75. Or 0.75 divided by 736 divided by 0.75 multiplied by Q, W, and H. So Q is the density of the water. Q is the discharge here, 1 meter cube. W is the density of the water, that is 1000. N is given as 100%, and H is given as 1 meter cube. So we can directly have 736 divided by 0.75. 0.736 divided by 75 multiplied by Q is given as 1 into W is given as 1000 into the efficiency is 100%, it means 1 into my head is 1 again. So the power developed is coming as 9.8 kilowatts. 9.80 kilowatts. This is a direct question, so please remember this formula also. 0.736 by 75, and this is coming in kilowatts. So please remember this formula, Q, W, and H. For this thing, we can go for another example. The last example in this, example number 7. It says that the maximum demand of a consumer is 2 kilowatt and the corresponding daily energy consumption is 30 units. So we have to find the load factor. Example number 4, 5, 6, and 7, which we have done, which we are going to do. 7th example is already asked in some objective type of questions. So please follow these questions. These are important questions. These type of questions can be asked in future examinations. So this is also an example which already been asked in some examination. So we have to find the maximum demand. We have to find the load factor when the maximum demand is given as 2 kilowatt and the daily energy consumption of a consumer is given as 30 units. So how to start with this question? So since the units is given 30 units, means 30 units means 30 kilowatt hours. So this is the daily. This is the 30 kilowatt is for day. So we have to find it for 1 hour. So for 1 hour, the consumption would be 30 divided by 24, which is coming as 1.25. So, what is this 1.25 now? 1.25 is the average load on our customers, and the maximum load is also given, so we can find the load factor now. So the load factor will be the average load, that is 1.25 now, divided by the maximum demand or the maximum load, that is 2 kilowatts, into 100%, which is coming as 62.5%. How we have proceeded to this question, we can understand it one more time, that the 30 units which is given here, 30 units is exactly equal to the 30 kilowatt hour in energy. This is the energy consumption for a day, means for 24 hours. So we need to find that for the load factor is supposed to be, since for the day, we have to find it for the per hour, on per hour basis. The load factor would be now here. So we have to find first of all the average load, which is called 30 divided by 24, that is 1.25 kilowatt is the average load of the customer. So the 1.25 divided by 2 will be giving me the load factor into 100%, that is equals to 62.5%. So we can have these type of examples in objective type of questions in examination also. So please remember the formula for load characteristics, and maximum time the load characteristics problems are asked in examination. So please remember these questions.